to explain Cambridge International AS and A-Level Pure Mathematics 3, October-November 2020, paper 31. Okay, so the first question asks solve the inequality, and the inequality has a modulus. We can eliminate this modulus by taking squares from both sides. So the first step is gonna look like squaring both sides, which gives us 4 minus 20x plus 25x squared, which is greater than 4 times x squared minus 6x plus 9. And we can get that equation out of bracket by multiplying that. So the inequality becomes this. And if we take all the terms and put on one side, it gives us equation 21x squared plus 4x minus 32 greater than 0. So what I got here is an equation that can be solved by quadratic formula. So you can write this quadratic formula plus or minus squared minus as this equation, which simply just minus 52 or this one. So that part of this equation gives us just 52. If you do it on your calculator, it gives 52 as a result. Which means, so solution 1 is this one. If you simplify, this one is just the 8 over 7, and the second solution gives us this one. Okay, since we took the squares from both sides, our equation had two solutions, but only one is real. So, which means we have to test our solutions. So let's just test it for x equals 2. So we set x equals 2, it gives us equation, this equation. And it gives us this one. And since minus 8 is clearly smaller than minus 2, this statement is false. And we can test for minus 2, which actually gives us, sorry, it's Yeah, and this is true, which means this equation is actually true, and this inequality is true, but this is not. Hence, the only solution is just -4 true. Okay. The second question asks, sketch on Argand diagram shade the region whose points represent complex number C, satisfying the inequalities. Absolute value of C is greater than 2, and absolute value of C minus 1 plus I is lower than or equal to 1. Okay, since we have to sketch Argand diagram, let's just draw this axis, and one is real, another one is imaginary. And for this question only, the maximum required space is just 2 from the origin, which means we can just this one as our diagram. So I'm drawing on my tablet, but you can draw this diagram on paper with your compass and pencil, which means your diagram is gonna be much better than mine. But just let me draw. So the first one, absolute value of z is equal or greater than 2, which means it's just a circle with center at origin and a radius of 2 from center. And the second one is this equation. So we can first plot. We have to plot 1 minus I in our diagram. So it's this one, and since it's given the requirement is equal or smaller than 1, which means its radius and like this one. So you can just present the region, the complex numbers satisfying these inequalities as here. So here is question 3. The parametric equations show curve x equals 3 minus cosine 2 theta, y equals 2 theta plus sine 2 theta. Show that dy or dx is cotangent theta. So there are parametric equations, so we have to take derivatives of these functions first. So the first step is dx or d theta. First, this 3 is constant, so we can just ignore that in taking derivatives. Next one is cosine 2 theta. The derivative of cosine 2 theta is 2 sine 2 theta. And dy d theta is applying the same rules. We have 2 plus 2 cosine 2 theta. So in the next step, you have to take dy over dx, which is actually equal to dy d theta divided by dx over d theta, which gives us this equation. If we write the cosine 2 theta and sine 2 theta as in just one theta in the brackets, if we expand them, we can get cosine squared theta minus 1 over 2 sine theta cosine theta. This actually gives us 2 plus 2 cosine squared theta minus 2. Wait a minute. I forgot 2 in here. Yeah. So it's actually 4. Since there's 2 minus 2, they cancel each other. Sine theta cosine theta. And 4 cancels each other, and 1 cosine and this cosine cancel each other, which gives us cosine theta over sine theta, which is actually inverse of tan theta, but in this case it's just cotangent theta.